Lesson 7-1, Zero and Negative Exponents. All right, so a couple important things to remember when working with exponents during this lesson. The first one to remember is whenever you have an exponent of 0. In our formula, anything raised to the 0 power equals 1. So 2 to the 0 power, 1. 8 to the 0 power, 1. That's our first rule to remember. And then second, whenever you have a negative exponent, we can make that exponent positive by moving the exponent to the denominator of a fraction. For example, 7 to the negative third power, if I switch the numerator and denominator, my exponent, notice on the bottom, 7 to the positive 3. So it went from negative to positive. Again, with negative 5 to the negative second power, I flip the numerator and denominator, and my negative 5 is now raised to a positive 2 rather than the negative 2. So keep that in mind as we go through this lesson. All right, another thing to note is that we can never have 0 as a base with 0 exponents, and here's why. All right, what I just told you, whenever you have 0 as an exponent, if I follow the pattern, our answer should always be 1. So 3 to the 0 power is 1. 2 to the 0 power is 1. 1 to the 0 power equals 1. If we continue the pattern, 0 to the 0 power should be 1 if we follow the rule I just taught you on the last slide. However, 0 to the third is 0. 0 to the second is 0. 0 to the first is 0. 0 to the 0 is 0. These two don't match up. It's not possible for 0 to the 0 power to equal both 1 and 0. Therefore, 0 raised to the 0 power is undefined. Same with negative exponents. If I had 0 raised to a negative 2 and I put that on the bottom, well, this is going to be 1 to the 0. And we know that having 0 in the denominator of a division problem results in an undefined answer. So we can't have 0 raised to the 0 power. It equals 0. Or it's undefined, sorry. And 0 to a negative exponent is also undefined. All right, first example, simplifying powers. Basically, what they mean by this is if you see a negative exponent, you can make it positive first before completely simplifying. So I'm going to move 9 to the negative second. I'm going to move that to the bottom or denominator, and now my second power becomes positive. And we know that 9 to the second power is 81. So 1 over 81 is our answer in simplest form. Doing one more example, look at A. 4 to the negative third. Well, I'm going to put that on bottom so my exponent becomes positive. And then 4 to the third is 4 times 4 times 4, which equals 1 over 64. Final answer. All right. Now, an algebraic expression, when we have variables, it's in its simplest form when there are no longer exponents that are negative. So here's an example. A. We have 5. I'm going to look at these as all different parts. Times a to the third times b to the negative 2. All right, well, 5 and a to the third are all with positive exponents. I don't have to do anything to them. However, b to the negative second, I can rewrite as 1 over b to the positive second. So my final answer, the 5a to the third stays on top because it was positive, and my b to the second power is what's going to go on bottom. So that's my final answer for A. Now if I look at B, 1 over x to the negative fifth. When you have a negative exponent on the bottom of a fraction, you can move it up to the numerator for it to turn positive. So I'm going to move this all up, and now I'm going to have x to the positive fifth power as my final answer. All right, and I'm going to skip these examples because they're just like the last two. All right, in problem 3, we're evaluating an exponential expression. When you do this, you can do two different methods in order to solve. In the first method, you're going to simplify first. That means if you have negative exponents, you're going to move them up or down on your denominator or numerator prior to substituting. If you choose method 2, you're going to substitute your values for your variables into your expression and then simplify. Either way works. It's really your preference. So I'm going to go with method 1. I'm going to simplify first. So 3 and s to the third power is positive. I don't have to do anything with that. But this t to the negative second, I can simplify. So I'm going to put t to the positive second on the bottom of my denominator. That reads 3s to the third power over t to the second power. Now I'm going to evaluate by putting my values for s and t into the expression. So I have 3 times, in parentheses, s looks like is 2, so I have 2 to the third power over t to the second power. Well, t is negative 3. Make sure your negative gets included when you square the number. So 2 to the third, 2 times 2 is 4, times 2 is 8. So I have 3 times 8 on top. And negative 3 squared is negative 3 times negative 3, which is positive 9. So I have 24 over 9, which simplifies to 2 2/3. There's my final answer. So simplify, then substitute, or substitute, then simplify. Your choice. All right, and in problem 4, our final example, it's just a real-world application problem. A population of marine bacteria doubles every hour under controlled laboratory conditions. The number of bacteria is modeled by the expression 1,000 times 2 to the h, where h is the number of hours after a scientist measures the population size. So we're going to evaluate this expression for h equals 0 and h equals 3. So really all I'm doing is I have my expression and times 2. First I'm going to put 0 in and solve, and then I have my expression again and I'm going to put in negative 3. So when I have 0 in my expression, that variable is measuring when the scientists measured the population of bacteria at the exact moment it was measured. The negative 3 means when the science measured the population 3 hours, or what the population was 3 hours prior to it being measured. All right, so anything to the 0 power is 1 times 1,000. My answer is 1,000. 2 to the negative third power, well, I'm going to rewrite that as 1 over 2 to the positive 3 power. So that's 1/8 times 1,000. I get 125 simplified. All right, those are your 4 examples. I would now like you to complete the lesson check and bring your answers to class.